For Lesson 4's homework, describing domain and range, we're going to take a look at some graphs and some equations, and we're going to try to figure out the best way that we can describe what our inputs, our x values, domain are, as well as our outputs, which is our y's, and our range. So if we look at this first graph, we very clearly have a starting point and a stopping point. So we know infinity is not going to be involved in this graph or in this domain and range because there are no arrows on it. Our domain goes from biggest x to smallest x. Well, if we look furthest to the left, 1, 2, 3, 4, our smallest x value that has a point here is -5. We have everything in between -5 and 1, 2, 3, 4, 5, 6, 7, 8, and 8. So our domain here, and everything's closed circle, so we get or equal to's. So -5 less than or equal to x, less than or equal to 8. If you like interval notation, you'd have square bracket, -5, comma 8, close our square bracket. For our range, we are looking at smallest y to biggest y. In other words, the lowest point anywhere on our graph to the highest point anywhere on our graph. So our smallest point here would be -1, -2, -3 for our y's. It's a closed circle. It looks like both of those points right there towards the top, it looks like the graph gets to be a maximum of 2. Again, if it's in the middle of the graph, it's assumed to be a closed circle. So then our highest point is going to be 2. If you prefer interval notation, we're -3 with a square bracket, comma 2 with a square bracket. Okay. If we look in the middle, absolute value x minus 3. If we were to graph this on our calculator, it would look like this. And the graph does not stop. It goes on forever in both directions. So therefore, if we look at our domain, well, it goes forever to the left and forever to the right. So we would have negative infinity less than x less than positive infinity. Or interval notation, our infinities always get parentheses. Another way to put this for the domain is all real numbers, because every single x value that we plug in works. Now for the range, we end up with a little bit different because there is a smallest point, and if you look on your table or you look on your graph, you'll find that that smallest point is when y is -3, closed circle, but then we have arrows pointing up forever, so then we are going to be less than infinity. Okay, interval notation, square bracket, -3, comma infinity, parenthesis. So this graph has a clear low point at y equals -3, but it goes on forever upward, therefore it has a maximum all the way up to infinity. And for our last one, we very clearly have a stopping point for our domain and our range, but then we have an arrow pointing all the way to the right. So our domain, smallest value, -1, -2, -3, -4 for x, closed circle, so less than or equal to. And since it goes on to the right forever for x is infinity. For our range, our smallest point is in that same location, except for the y value here, it's at 0. It's right on the x-axis. So 0 less than or equal to y. And although this arrow looks like it's pointing mostly to the right, it will continue to go up and up forever. Therefore, our range is also to infinity. Okay, and I'll just show you a couple different ways that we could write this. We could have -4, comma infinity, okay, with a parenthesis. And also, I'm just going to pull my range down a little bit here. Another way to write that same inequality would be x is greater than or equal to -4. For our range, we can go square bracket 0, comma infinity. And also another way to write that inequality would be y is greater than or equal to 0. So all of those are equivalent to each other, all in blue, all in red. It's just kind of which way you prefer. For the second one, we want to graph the function y equals parentheses x minus 4, close parentheses, squared over the interval x is less than 1. I would strongly suggest here that we plug this into our calculator and look at our table and look at our graph. Now the key to this problem is going to be this piece right here. They only want us to graph the x values that are less than 1. So the biggest point that we are allowed to graph is when x is 1. So I'm going to put that at the bottom of my table. And then I'm going to graph a whole bunch of points less than that. So 0, -1, -2, -3, -4. And a lot of these points actually aren't going to fit for this graph, which is going to make things fairly interesting. So actually what I'm going to do is I'm going to make an adjustment in this problem. And I'm going to change this so that we have something that works out a little bit better. I'm going to change this to x is less than 6. Let's do that. So we're going to take the same idea here into our problem where all of our x values have to be less than 6. So when we go to make our table, 6 is our biggest value. 5, 4, 3, 2, 1, and I don't think any of the other points are going to fit. So what we want to do is we just want to copy our table down from our calculator. 9, 4, 1, 0, 1, and 4. The key is right here though. It says x is less than 6, meaning 6 is not included, everything up to it is. So when we graph our point at 6, we are going to have an open circle. So I'll start at 1, 9, 2, 4, 3, 1, 4, 0, 5, 1, and then an open circle at 6, 4. And because it's squared, we're going to end up with a parabola, which is our U shape. Now, because they told us where exactly a stopping point was, we might have our parabola be unbalanced here. But we also didn't have to stop when x is 1. We chose to stop there because that's all that fit on the graph, but there is still going to be an arrow only on that side because we can go less than that point, but we can't go more than our open circle, which is why there's going to be no arrow on that part. They want us to describe the domain over which the function is decreasing. So remember, decreasing is as you go from left to right, your graph is going down. That would be this part of our graph right here. But remember, we have an arrow on there. So therefore, this graph really is going to keep going to the left and to the left forever if we let it expand. So where does the decreasing really start? Well, it starts at -infinity. And it stops decreasing at the bottom of our parabola. So it's going to stop decreasing when x is 4. And we are just going to use a less than sign. We're not going to use the or equal to for this part. And it stops when x is 4. If we want to use interval notation, it's -infinity, 4. Both pieces are going to get parentheses in this case. And we end up with our graph going on to the left forever. So that's why it starts decreasing at -infinity. It stops decreasing at the bottom of our parabola when x is 4. So our interval is -infinity to 4, both with parentheses.